Solve the equation for theta is in between 0 and 2 pi. So I'm given 3 sine theta plus 2 sine squared theta equals negative 1. Well, why don't I add 1 to both sides and set it equal to 0? By doing that, and maybe rewriting it in a clever way, I have 2 sine squared theta, because now I'm writing it in standard form because I have a feeling I know what's going to happen, plus 3 sine theta plus 1 equals 0. Now, make believe that sine is a. So I have 2a squared plus 3a plus 1. And if you're thinking, oh, that's something I can factor, you're thinking the right thoughts. But a is sine, so I have to treat it as such. So that factors out to 2 sine theta plus 1 times regular sine theta plus 1. And if you FOIL that out, you'll realize that I'm right. Trust me on this one. Now I have zero product properties. Set them each equal to 0. So 2 sine theta plus 1 equals 0. Subtract 1 from both sides. Divide 2 from both sides. And now sine theta equals negative a half. Okay, if I inverse sine both sides, and I'm running out of space, so I'm hoping that this shows up in the video. If I inverse sine both sides, I have theta equals the inverse sine of negative 1/2. Now, the inverse sine of negative a half is asking me, where is the sine or the y value going to equal negative 1/2 on the unit circle? Well, that happens at 2 spots, 7 pi over 6 and 11 pi over 6. So that's answer number 1 based off of the left side of this zero product property problem. Now what I have is a slightly easier one where it's sine theta plus 1 equals 0. I subtract 1 from both sides, so sine theta equals negative 1. I inverse sine both sides, so theta is going to equal the inverse sine of negative 1. Now where is the y value negative 1 on the unit circle? Only one spot, and that's going to be on the negative y-axis where 3 pi over 2 exists. So yeah, that's it. That's 3.12. Lots of solving for trig stuff.